move on to the last strategy, all right, which is strategy number 9, external change or external transfer with change quantities. Now, some teachers or some books may use different name. Have you heard of the BCA technique or BCA method? Before, change, after? Yes. All right. So we are going to use this strategy, and sometimes they call it before, change, after. All right, before, change, after, or before strategy and after strategy. Right? So there are various names. Not to worry. I will show you the what are the strategies to solve this kind of question, or what are the common features of this question. Okay. Strategy number 9, external change and external transfer with change quantities. So when do you use this strategy? Is to solve a problem involving changes to both quantities. That means the quantities at the beginning and at the end are different. So what strategy we can use? We can use the guess and check again, or we can use the simplified model method or the BCA method. Now remember, in the last webinar session, we talked about total unchanged, okay, and we also discussed about external unchanged. So in external unchanged, only one of the quantities are changed. The other one remains the same. But in this question, it is a little bit challenging because both quantities are changed. Okay, I'll show you this question, then you can understand better. So you can see here in this strategy, quantities are different at the beginning and at the end, and it involves changes to both quantities. Okay, so the ratio of Johnny's marble to Ethan's marble is 1:5. So this is the before ratio, 1:5. Their mother gave Ethan 12 more marbles and Johnny 5 more marbles. So you can see here it is different. 12 given to Johnny, give to Ethan, and 5 given to Johnny. So Ethan was given 12 more marbles and Johnny was given 5 more marbles. In the beginning, the ratio is 1:5. And what happened in the end? The number of Ethan's marble to number of Johnny's marble became 4:1. In the end, Ethan becomes 4 units and Johnny is. Why there's a difference at the end? Because of these two changes. Changes to Ethan, where Ethan was given 12 more marbles and Johnny was given 2 more marbles. Okay, so a little bit challenging here because both of the quantities change, right? Now let's take a look. So you may use the guess and check method again. And remember the ratio in the beginning is 1:5. Okay, so 10, 1:5 multiplied by 10, multiplied by 10, you get 10:50. So if Johnny had 5 more marbles, okay, you plus 5. Ethan had 4 more marbles, you add 12 to 50. Okay, and you can see here 15:62. Now, does it meet the ratio at the end ratio? 1:4. It doesn't, right? So then you move on to guess. What if the ratio is 20:100? So if Johnny is given 5 more marbles, you get 25. Ethan given 12 more marbles, you get 112. Now, do we get 4:1 at the end? Again, no, right? Okay, so next we try 4:40. Sorry, 8:40. 1 multiplied by 8, 5 multiplied by 8, we get 8:40. So Johnny was given 5 more marbles, 8 plus 5, we get 13. Ethan was given 12 more marbles, 40 plus 52, 40 plus 12, you get 52. So you can see here the ratio is 4:1, right? So it meets the requirement of the after. So you can see that this question involving guess and check, and okay, assuming that you can get 3 guesses and you get correct, then it's quite fine, right? It's quite fast. But if you have to keep on, guessing and guessing until, it's going to take quite a bit of time. Okay. Now I'm going to show you this strategy called external change method. Okay. So first, how we do this method? Step number 1, we draw a table and give the appropriate headings. So you can see here, before, change, after. Okay, so some of you may know BCA method, BCA. Okay, BCA method. So the ratio of Johnny's marble to Ethan marble is 1:5. Okay, 1:5 in the beginning. So their mother gave Ethan 12 more. So Ethan plus 12, right? And Johnny plus 5. So what happens in the end? Okay, in the end, it is 4 here and 1 unit here. Okay, let's take a look here. So this is before 1:5 units, after plus 5 plus 12 for Ethan. Okay, the change, and then after in the end, it becomes 1 part and 4 parts. Now take note, I purposely use units and parts. Okay, why? Because we do not want this part here 1:4 is different from 1:5. So that's why we use a separate term 1:5 units. After unit, I call it 1 part is to 4 parts. Okay, so that you not confuse between the before ratio and the after ratio. So what we need to do next is we need to make the parts the same. We need to make the parts the same. How do we make the parts the same? We find the lowest common multiple of the parts. So this is 1 part, this is 4 parts. What's the lowest common multiple? Yes, lowest common multiple is 4. Excellent. All right. Okay. So if I want to make 4 here, everything I must multiply by 4. So 5 times 4, I get 20. All right. 1 times 4, I get 4. 1 plus 4 times 4, I get 4 here also. Okay. So since I need to make both parts the same, okay, so I find lowest common multiple of 1 and 4, which is 4. So multiply by 4. Every part here, I must multiply by 4. All right. So what do I get then? So I get 4 units. Why 4 units? 1 unit multiplied by 4, I get 4 units. How I get 20? 5 multiplied by 4, I get 20 here. And here, number of parts is the same. So now you can see here, the number of parts is the same. Why do I do this? Why? Since that 5 units of Ethan plus 12, I get 4 parts. Likewise, 4 units of John marble in the beginning plus 20, I also get 4 parts. So what does it mean? It means that 4 units plus 20 is equals to 5 units plus 12. Okay, 4 units plus 20 equals to 5 units plus 12. Now before, we cannot equate this to here. Why? Because the number of parts are different. So that is why we make the parts the same. Right? In the earlier step, we make the parts the same. Initially was final ratio 1:4. Now you can see that this is 4:4. Okay? Then you can see here, 4 units plus 20 is equals to 4 parts. Likewise, Ethan, 5 units plus 12 is equals to 4 parts. Okay. How do I get this? How do I get this model? 4 units plus 20, I get 4. You can see on the right side here, 4 units plus 20, I get 4 parts. Likewise, for Ethan, 5 units, okay, 5 units plus 12, also I get 4 parts. Okay, so for Ethan, it will be here. For Johnny, it will be here. Right? So I can equate these two bar. Why? Because I've made the number of parts the same. Okay. So what you can observe here, 4 units plus 20, 5 units plus 12. So 1 unit must be, 1 unit is from here to here, right? Must be 20 minus 12. 1 unit, right? Since here to here is 5 units, here to here is 4 units. So this is 1 unit. So how do I get 1 unit? 20 minus 12, okay, which is 8. So 1 unit is 8. And then they ask you, how many marbles did Ethan have at first? Ethan has 5 units, right? So 5 multiplied by 8, I get 40. So Ethan has 40 marbles at first. Okay? Questions? Any questions? Have you all seen this strategy before? You have not seen before? Fish, Trinity. Did my first question in my activity book. Oh, well done. Very good. Okay, some of you, okay, good. But it's very hard to do. Okay, Iman, it's not hard. Okay, the key here, okay, let me repeat one more time. I'll just repeat one more time. So what you need to do here is that you draw a table. So, and then Johnny marble is 1:5. You can see here 1:5. And then what is the change? Okay, Johnny increased, number of marbles increased by 5. Ethan increased by 12. In the end, the ratio is 4:1. Right? In the end, 4:1. So we cannot compare these two parts first because the parts are different. So what we do next, in the next step, we make the parts the same by finding the lowest common multiple of the parts. This is one part, 4 parts was lowest common multiple, 4, right? If I multiply by 4 to one part here, plus 5, I must also multiply by 4. 1 unit, I must also multiply by 4. So what do I get next? I will get 4 units plus 20 equals to 4 parts. For Ethan, 5 units plus 12 equals to 4 parts. Since both parts are the same, so I can equate these two together. Okay, Johnny's marble, 4 units plus 20 is equals to Ethan marble, which is 5 units plus 12. Right? So then I draw a simplified model, and you can see very clearly here that 1 unit is 20 minus 12, which is equals to 8. So 5 units equals to 40. Why? Because the question asks how many marbles did Ethan have at first, which is 5 units. So 5 multiplied by 8, I get 40. So Ethan had 40 marbles at first. Okay, I hope you understand. All right, so we have come to the end of today's session. I've extended a little bit of time. Okay. All right, let's take a few questions. Talha, you said that yes, but my teacher said must make the pair of ratio the same. Okay, which is exactly what we have done. Okay, we make the parts the same. Instead of drawing the model, can we cross the bridge method? Okay, Zafir, yes. Instead of using the model method in the end, you can also use the units method. Okay, units method, it is similar to algebra. Yes, perfectly fine. But I show the model method because some students may not be familiar with the algebra method, of switching from the left side to the right side. Okay, yes, perfectly fine. You can use the algebra method. Okay, what is the algebra method? Okay, so you can see here. Okay, I'll just show you. Since the parts are the same, right? So you can see here 5 units plus 12 is equals to 4 units plus 20. Okay, so what you need to do here, you bring the 4 to the other side of the bridge. So you get 5 units minus 5 units. I think this is what Zafir is mentioning about going to the other side of the bridge. Very interesting analogy. So 20, so 12, you bring this 12, you bring to the other side of the bridge. So you get 20 minus 12. Okay, so you get 1 unit. So 4 units minus 1 unit, you get 1 unit. 20 minus 12, you get 8. So you get exactly the same answer as this. Okay, so for those of you who do not know this method, this is actually algebra method. Okay, this is not this is actually algebra method. Sometimes if for those of you who can understand, it's good, right? But if for those of you who don't understand, okay, you can use the simplified model method to see. Okay, right. Any other questions? Okay, Haziq asks, if percentage and fraction are in one question, will we be able to use the branching method? Yes. If you want to use the branching method, my suggestion is to convert everything into fractions. Okay,